Hey there developers, this is part of a series going through what the solid principles are. Today we're going to go through the third of them, the Liskov Substitution Principle. The Liskov Substitution Principle was introduced by Barbara Liskov in 1987, and it's the only one named after the person who defined it. It tells us how to define our classes so that you can easily substitute them with another class derived from the same one without breaking your code that uses it. So let's imagine your original class requires something to work with an integer. Now your derived class based on it requires that integer to be greater than 10. This is strengthening the preconditions of your class so that any code that had worked just fine before, where the value would be less than 10, would now be broken. And this violates the principle. But the other way around, where it started off as requiring a value greater than 10, and then you derive a new class from it and change it so that all numbers are allowed, well, that's okay because you wouldn't be breaking the original code because of it. So that's a really simple example, and it's probably not one you'd ever see in the real world, but really it makes us think more logically about how our classes and our hierarchies are defined and put together, and that can't be a bad thing. So if you're not confused yet, let's go through an example. And sometimes using the animal kingdom as an example of inheritance is a good place to start. So let's start with a bad example. So what we have here is a series of classes, and we're using some inheritance to show the principles of Liskov. So we're going to start off with a bird class, and all birds have feathers, and I've googled that. Apparently that's true. We're then going to inherit another class from it called starling, and starling is a bird, so therefore birds have feathers. And we're also going to have the same inheritance for emu. Emu is also a bird, and birds have feathers. So far, so good. Seems logical, right? But we then decide that we want to add another property to bird. And that property is can fly. Now, that seems logical. Birds can fly, right? But no, they can't, because emu can't fly. And we've just forced all birds to be able to fly. So this breaks the principle. We've strengthened our original class, and it's now broken something that used emu. So somewhere where we're working with the emu class, we've just broken it because we've added something to a previous class. So this kind of breaks the principle. It's a very simple example of it, and it's again something you probably wouldn't worry about because just adding a property wouldn't cause an issue. But just as a general example, that could cause an issue. But more is trying to tell you how to structure your classes. So the first part of Liskov is just making you think about how to structure classes in a way which makes more sense. So if we were going to do this again and make it look a bit more sensible, how would we do this? Well, we're obviously never going to go straight and create an emu class anyway, but emus can't fly, but some birds can. So really, we need to have another class called bird that can fly. Worst name class ever, but you can see where I'm going with it. And inside that, we say can fly, which is an extra property. And then we can tell the starling class that it has an extra property called can fly. And it no longer breaks emu. And if we wanted to use birds that can fly, we just have to inherit from bird that can fly classes. So that's the first part of Liskov. It's allowing us to think about how our classes are structured so that we don't cause problems further down the line. Okay, so let's have a look at an example of pre and post conditions. So we've looked at how classes should be better structured according to Liskov, but we should also look at when we're calling a method, and that method has some restrictions on it about what happens to the data that goes into it and what comes out of that method. So I'm going to put into an example of, say, we want to have access restrictions to something. So I've got a person's name. I'm going to pass that into a function. That's going to tell me if I've got access to something or not. So if I put in a new class called access, and I'm going to put in a method which tells me if I have access to it based on my name. And if my name is greater than 0, then I'm going to tell me yes or no will be returned. I'm not using booleans for a very specific reason here. You'll see that in a minute. So this seems like a fairly sensible class to think about. I've given you a name, and everyone who's got a name has access. It'll return yes or no based on that. Everything's fine. But then we come along later on and we decide we want to put in a new variation of this. So we're going to put in a new class called special access. Okay, that's going to inherit the original class. At this point, there would be no difference. We're just inheriting the original class. Everything would be exactly the same. Now, you could imagine this class has lots of other things that we want to do, lots of other changes, but we decide as part of that we want to change the way that can access works. So we decide to come in and change can access and we decide that we're going to make it harder to get in to this class. There we go. So we've decided that we are going to strengthen the access restrictions. Now that's strengthening the precondition. The precondition of the name being greater than 0, we now made it greater than 10. Anybody who then uses this special access instead of access, so if they want to replace some other functionality, but as part of it, this has been strengthened, that's going to break their code, because you might have somebody called Bob who's only got 3 letters in there, and all of a sudden he can't get access anymore. So doing it this way round is considered to break the principle, because we're sort of restricting those preconditions, those inputs that are going in, and we're making it harder for us to use this and breaking our code. Now, the post conditions, the stuff that comes out of this, can also break Liskov. So if for some reason I decided to change this to true and false instead, that's also breaking Liskov, because we've all of a sudden made a decision to change the post conditions, the output from this function, so that now anything that calls this will be looking for yes or no, but actually they're going to be getting true or false back, and that's broken. So Liskov's trying to tell us to keep our outputs the same, but the format of the output to be the same. Now, it doesn't say it has to be yes or no in a strict format like that. It could be the data type has to be an integer or a double, or the range that we're using. But really, having these preconditions this way around isn't great either. What would not break it is changing it this way around, so that the original class said you have to have a name of greater than 10. Then the inherited class actually loosened that restriction, that precondition, and said, no, actually anybody can access it now. Why doesn't that break Liskov? Well, because your original code would still work. You put somebody's name in whose name is greater than 10, and they would still get access. but you replace that with special access where anybody put their name in and it would still let them have access. This might seem a little bit weird when you talk about it in terms of a simple example like this, but when you start building more complicated systems, it actually makes more sense to have more strict classes, and then when you inherit them, they don't make it even more strict so that your code can be broken as a consequence of it. So it's quite a complex principle. I'm hoping that these couple of examples have helped a little bit to break it down. But hopefully it does simplify the Liskov substitution principle for you. Thanks a lot. Make sure you hit that subscribe button and switch on the bell icon to get all notifications, and we'll see you in another video.